As for demo, I want to show our images and codes which simulate noise change in D and pen angle change, as well as reading the data. First of all, I read the 3 data sets in here. For the demo purposes, I only process the third image, which is a chest view, and noise-free data is illustrated and projected via built-in functions and made function, and then IFM beam is reconstructed the image. Then noisy data is created here, and inside the for loop, the different combinations of noises created, and then for both cases, and then the values are changed again inside the for loop, and then gamma angle is changed inside the for loop to see the effects of the output, and the function used in the handwritten one is as such. When I click the run button, I need to wait a second. And the figures are as such. And if we looked at the figure 3, which is an original value, this, and figure 20 and 21, which shows the sinogram of change in the D, and also if we looked at the figure 21, its output result, and in figure 23, the result is as shown, the gamma change.
Now we can move on to the demo part, where I will be showing the different types of filters as well as the application of the external codes. So here, first of all, we have our 3 images, and we can choose any of them in order to apply our filters. Here are some of our generic parameters for our projections, and here is the code where we try out different filters and their effects. So now we can run the code in order to see the effects of the filters. So here is our original image, as we can see, and we will be trying to reconstruct it. So first of all, here we can see the unfiltered image, first of all. So here we can see that, similar to the slides, it is very blurred and it is very bright. And here, for example, we can look at a filtered version of it. And here, for example, we applied hand filtering to it, as we can see here, and it is much better as compared to its unfiltered version. And then, for example, here we have a different filter, and this filter is Hemming, for example. But as we can see here, there are not much differences between different filter types, but rather performing filtering is important. So now we can close these ones and move on to the other version, the other part. So here is where we perform our external codes, fan beam filtered back projection. So here again, we applied it to our first and third image. So we will be now simulating the first one. Here is our projection part, and here is our reconstruction parameters. And here is the part where we reconstruct, and this is our projection function. So now we can run the codes in order to see the procedure. So first of all, this is our original image, and this is its sinogram. And here, first of all, we can see the reconstruction procedure step by step, which was something very beneficial for us. And it is important to show that, for example, the external image was performed in blocks of codes, which made its implementation very efficient. And here, as we can see, once again, the features became apparent here in this image, so we can consider it as a successful attempt in reconstruction, first of all. And once all the reconstruction procedure is complete, is completed, we will be able to see the filtered back projected and in this external code weighted back projection at our screen. Shortly, we will be observing it. Yes, and here we can see the reconstructed image using the external codes, and this is the same image that we have saw on the slides. So again, we can consider it to be a successful attempt as we are able to see and understand from this image the original version.